Okay, so this is going to be the 18th problem in the Grind 75. This one is called Longest Palindrome. We are given 20 minutes for this, so we're going to start the countdown now. Okay, longest palindrome. Given a string S which consists of lowercase or uppercase letters, return the length of the longest palindrome that can be built with those letters. Letters are case sensitive, so this is not considered a palindrome. All right, so let's see. String can be really long, consists of upper or lowercase. One longest palindrome that can be built is okay, so I guess it's the longest substring that is a palindrome, and we can have upper and lowercase letters. So let's see. Well, I already see a base case, which is an example 2. So maybe input size 1 base case. Let's look at example 1 a little more closely. So it's DCC ACCD. Oh wait, they can be built with those letters. Wow, okay. Okay, so to me what it seems like is we can have, so we're going to need, so one, we're going to have to go through the entire string. So get counts of every letter in string. I'm thinking hash map of some kind. Another thing we're going to have to do, so we're going to keep all letters of even counts and then pick pick letter with largest odd count. Okay. So it's kind of interesting. So one that sort of seems like we have to iterate through the hash map, so how do we want to do this? I mean, remove would also cost something. So the only thing that I'm sure I would be able to do everything else, but iterating over a hash map. I'm not sure that's something you usually do, but is there a better way to do that? So I'm just going to go over my thought process completely. So I'm going to ignore the base case for now. We're going to iterate through the string, and we're going to look at each character, and if we have seen the character before, then we're going to increase its count in the hash map, where the key will be the character and the value will be its count. If we haven't seen the character before, then we're going to add it to the hash map. And once we go through the entire string, we're going to take everything that's even, and then pick something with the largest odd count. And then the way that we would build that is another thing. How to build. I mean, that's, I mean, I'm thinking stack in some way, but that's just the word that comes to mind. I'm not really seeing how that would work. Let's see. So given example one, I'm going to say, so example one, our hash map would look something like this. So we would have A1, we'd have B1, C4, and D2. So we would keep our evens, we would take any of the odds in this case, but the largest one. And then we would have to construct the palindrome. Oh, wait. Do we have to? Return the length of the longest palindrome. Oh, geez. Okay. Read the problem description. That will help you out a lot. Return the length of the longest palindrome. Okay. So, yeah, then I guess the only question I really have is iterating over a hash map. I guess we can just, I mean, if worse comes to, well, no, I don't want to do that. I mean, I was thinking that I would iterate through every lowercase and uppercase letter, but I guess another thing I can do is like first key, I believe, is a method for hash maps, and then remove that. So basically I would look at the top value, check if it's even or odd. If it's odd and it's greater than our maximum odd value, then we'll keep it. If not, we'll discard it. So, okay. So I'm going to start by making the implementation right now. So we're going to need that hash map again. So this hash map is going to be of characters, and it's also going to have integers. And this one is going to be called char counts, and it's going to be equal to new. Same thing over here. It's a new one of those. And then I guess another thing we can do is max odd, which will be instantiated to 0 because we might not have any odd counts of letters. Let's see. So then the first thing we'll do is iterate over everything in the string. So we can say for char C in S, and we got to convert that to a character array. We're going to do what we typically do, which is check if it's contained. So if char counts dot contains C, the character will be the key, then we're going to do char counts dot put C and char counts dot get C plus 1. If that's not the case, then what are we going to do? We're going to add it. Else we're going to add it to char counts. So char counts dot put C0. Okay. So everything will be properly loaded, characters and their counts. And then we are going to go over the hash map outside of this for loop. and I'm going to say max odd and then integer total. Right now it's going to be equal to 0. And we're going to say while the hash map is not empty. So while what is it called? Char counts dot is empty is false. So while it still has values in it, we are going to take a peek at the value. So we're going to say dot first let's say int divisible is equal to char counts dot get char counts dot first key. I'm really hoping this is a method that's built into hash maps. Might actually be like this first key. I feel like I've seen it before, but I've never actually used it. So let's see, divisible, and we're going to say if divisible mod 2 is equal to 0, then we know we're going to include it in the palindrome, so we're going to say sum plus equals divisible, right? The count. So I guess count would be a better, you can say letter count. That would probably be the best name. If letter count is divisible by 2, and we're going to add it to the sum, else, we're going to say else if actually letter count is greater than, I can say greater than, doesn't really matter. I'll just say greater than max odd, then we can also add it to the count. But this, we're not going to add it to the count right away. We're going to just add it to max odd. Max odd is going to be equal to letter count. Okay. So we're going to get through the whole thing. And then what we are going to return is total plus max odd. Okay, so I believe this works. The only thing I'm unsure of is if we are getting values from char counts properly, we also need to take that out. So you're going to say take off the top value. So char counts dot remove char counts dot first key. And unfortunately, I'm actually going to pause really quick just to look sure, or just to make sure that this is an actual method that we can use for hash maps in Java. So let me pause really quick. Okay, so technically we can use first key, except we have to change our hash map to a tree map, where a tree map is pretty much just a sorted hash map. And this is a Java specific thing. This was very helpful in a project that I did at school, but yeah, that should be good actually. I'm hoping that removes, well, yeah, it's going to remove the same one each time. Okay, so this should work. Let me just run the example really quick. Just yeah, do we have any syntax? Integer should just be integer. Let's see. Oh, integer is here as well. What other errors? Char counts dot contains. Char counts is a hash map, so I keep making this mistake. It has to be contains key. Sum plus equals divisible. See, do I have divisible? No, it's called letter count. Letter count. $17. Okay. Line 8. Okay, that should be good. Sum plus equals letter count. Sum, it's because it's total up here. Okay. Is that the only error? Okay. Wrong answer. Okay, output is 3, expected 7. Why is that the case? So, I mean, we can just go through it. It's for each character in the chart array. It's already there, we can increment the count, otherwise, okay, so actually, we're gonna want to do that. We don't want to start it off as zero. Could that be the issue? Could it really be the issue? Okay, that might have actually been the issue. Let's see. Oh, that was not right. Okay. Maybe there was something I missed. I mean, the examples seem to be pretty good. Let me just look through this again. So once we get the tree map, it's going to be ordered. We'll have the counts for each letter. But let's see. Well, the solution is there. Did not mean to look at that. Well, I didn't actually see anything, but okay, I made the same mistake again. Output is way off from expected input. I'm just going to look at the examples again and see if there is anything we did wrong. Add it to the chart array. Contains the key, then we're going to increment. Otherwise, if it's not there, then we're going to put it in. We're going to add 1. And while char counts is not empty, then set letter count equal to that. If it's divisible, then we're going to add it to our total. Okay. Else if letter count is greater. So yeah, so if it's not divisible by 2, then we know it's odd. If it's greater than the current maximum odd, then we're going to set the max odd equal to that. And we're going to remove it, that letter from our collection of letters. And we're going to return the total max odd plus total. So, I mean, that seems to work. I wish I knew what I was missing. Why are so many letters just falling off? I have gone, I pretty much hit the time. I'm going to stop the video here, actually. So, see you in the solution.